Hello everyone. So this is my second question, which is based on strain energy. So here in this question it says that a mild steel plate is 400 long and 200 in wide, and its thickness is 50 So here see, so here it says that the the length of this steel plate is 400 and the width is 200 and the thickness of this plate is 50 So it's subjected to gradually applied load. So in this problem it's already given that we have to use this method, that is gradually applied load. So the load is of 1200 kilonewton. So here the load which is acting in this plate is of 1200 kilonewton. Okay, so now here what we need to do is we need to calculate the proof resilience, modulus of resilience and the elongation. So here proof resilience, what does this mean? Here it is nothing but the maximum strain energy which is stored inside the material is known as proof resilience, and modulus of resilience is the strain energy per unit volume. So strain energy per unit volume is the modulus of resilience. Now elongation is nothing but the change in length. Change in length, when it will happen, suppose see, when we will apply a load in this bar, what will happen? Due to this load, this bar will get elongated. So that elongation, there will be a change in the length, because see here before the length of the bar was 400 When we pull this bar, obviously the length will get increased due to this applied load. So this change in length delta L is the elongation. So here in this question, E is nothing but the modulus of elasticity is given, that is nothing but 200 into 10 to the power 3 megapascal. So now I will solve the problem. So here first thing we need to find is proof resilience. So proof resilience, so we know the formula for finding the proof resilience, that is strain energy. Strain energy is denoted by the term capital U is equal to sigma square by 2E into volume. So now first we need to find the stress value. Stress, how we'll find the stress value in case of the gradually applied load? Gradually applied load, so stress is equal to P by A, and this explanation have already been done in my previous video. You can go and check it out. So now here P is given in the question, that is 1200 into 10 to the power 3 upon A. Area is nothing but the, see in the question everything was given. It was 200 and the length is 400 and the thickness is 50. So the area, the cross sectional area of this plate is 200 into 50 is equal to 200 Newton per square. So now we got the value for the stress, that is 200 Newton per square. Now we can directly put the values in the main formula, that is U is equal to sigma square upon 2E into V. So sigma is 200 square upon 2 into E is given in the question, that is 200 into 10 to the power 3 into V, volume of this plate. So volume of this plate will be what? area into the length cover. So what is the area is 200 into 50, and the length of this plate is nothing but 400. So if we evaluate this, we'll get the value around 144 into 10 to the power 3 Newton millimeter. So the first here, so we got the value for proof resilience. Now next is to find the modulus of resilience. Modulus of resilience. Okay. So now what will happen here? Modulus of resilience is defined as the strain energy per unit volume. So we know the formula for modulus of resilience, that is U is equal to sigma square upon 2E. So we have a values for all the this one. Sigma is nothing but the 200 square upon 2 into E. 2 into E is nothing but 200 into 10 to the power 3. So we'll get value around 0.036 Newton per mm square. Now here the third one is what we need to find is the deflection, elongation. So elongation. So we know that elongation is denoted by the term delta L. Delta L is nothing but the change in length, is equal to sigma L by E. So we have all the values for this, that is sigma is equal to 200 into L is nothing but 400, and E values given, that is Young's modulus, is 200 into 10 to the power 3 is equal to 0.24 millimeter. So now see, in this question we have asked to prove resilience, that is this is the value for proof resilience, and second is to find the value for modulus of resilience, that is this is the value for modulus of resilience, and the third one is the elongation, and delta L is nothing but 0.24. Thank you.